Picture this, a cold, moonless night shrouded in heavy mist. As you cross the road, thick fog obscures both the sound and headlights of an approaching vehicle. By the time you notice, it's too late. You brace for impact. Suddenly, an elderly stranger appears from nowhere and shoves you to safety, only to be struck by the car themselves. They lie motionless on the pavement as your life continues. Later, a police officer approaches with an envelope discovered on the deceased. It bears your name. Inside, a note with just 2 words: "Study physics." This mysterious note saves your life at someone else's expense, compelling you to honor their sacrifice. Decades pass. You become a distinguished physics professor specializing in Einstein's theories of relativity. Time travel has always intrigued you, and one extraordinary day, you achieve the impossible. The world's first functional time machine hums with energy before you. At that moment, realization strikes with devastating clarity. The power to traverse any point in space-time now rests in your hands. Yet you understand exactly what must be done. You retrieve the framed letter from your wall, place it carefully back in its envelope, and slip it into your pocket. Stepping into your time machine, you configure the controls for that cold, misty night from your youth. You emerge precisely when needed to push your younger self from the vehicle's path. You collapse on the roadside, your journey ending as theirs begins. The temporal loop closes. This appears straightforward initially, yet deeper examination reveals profoundly troubling questions. Who actually composed the letter? Your older self merely transports the letter they received decades earlier backward through time. The letter exists as an apparently authorless entity, perpetually cycling through time. This represents the Bootstrap Paradox. The letter possesses no origin point, no moment of creation. It simply exists, transferred from future self to past self in an eternal cycle. This information appears from nowhere, contradicting our basic understanding of cause and effect. Additional paradoxes emerge upon reflection. Do these temporal loops repeat indefinitely? You rescue your teenage self, who matures to journey backward, saving their teenage self, who matures to travel backward repeatedly. You're imprisoned in a relentless cycle of living and dying. But what about the letter itself? Does it continuously age and deteriorate with each cycle? This constitutes the restoration paradox. Furthermore, whose concept was studying physics originally? The idea materializes without origin, the Ex Nihilo Paradox. If such events occur, free will appears non-existent. No genuine choices exist. Inventing the time machine was inevitable, offering absolutely no alternative. It had to happen, it always happened. Without creating the time machine, you cannot rescue your teenage self, meaning you would perish as a teenager. Something in your future remains firmly fixed. This represents the Predestination Paradox. What if you reconsider? What if you refuse entrapment in this loop? Unfortunately for your older self, this option doesn't exist. You cannot develop cold feet and allow your younger self to be struck. How could you exist to have second thoughts initially? This exemplifies the auto-infanticide paradox, seemingly impossible to eliminate a younger version of yourself even through inaction. Therefore, not such a simple story after all. Welcome to the bizarre and wonderful realm of time travel physics. But naturally, you might argue that freely traveling through time is impossible. You cannot simply visit yesterday or rush through millennia. Yet this assumption isn't entirely accurate. Despite numerous impracticalities, possibilities exist at physics's edge, temporal loopholes lying just beyond reach. The question arises, if time travel proves possible, how might we accomplish it? Scientists have revealed that the past, present, and future exist alongside one another, much like different locations in space. Philosophers know this concept as eternalism, opposing presentism, which argues only now exists, while past vanished and future awaits emergence. To physicists, eternalism constitutes the block universe theory, founded upon Einstein's celebrated general relativity, among science's most successful theories. In 1905, Einstein published special relativity, eliminating Newton's absolute time notion. No universal clock exists for everyone to agree when something occurs. Before Einstein's realization, everybody assumed time was universal, with Newton imagining a cosmic clock relentlessly ticking forward. Einstein realized this universal cosmic clock was fiction. Time's passage depends on who's moving and who's observing. Time dilation represents one of relativity's most extraordinary predictions. The faster the relative velocity, the greater the time dilation between observers, with time slowing towards stoppage as one approaches light speed. Theory suggests time dilation enables passengers in fast-moving vehicles to advance into the future rapidly. Astronauts traveling at 95% light speed for 10 years would return finding their Earth-bound twin aged 32 years. This isn't science fiction, it's experimentally verified physics. After 6 months aboard the International Space Station, orbiting at 7,700 meters per second, astronauts age approximately 0.005 seconds less than on Earth. But what about traveling backward through time? Some solutions to Einstein's equations suggest suitable space-time geometries or specific motions might allow time travel into the past. Physicists discuss closed timelike curves, world lines forming closed loops in space-time, permitting objects to return to their own past. However, backward time travel introduces potential causality problems. The classic example, the grandfather paradox. You use your time machine traveling backward to eliminate your grandfather as a child. However, this means he never reaches adulthood, never meets your grandmother, so your mother is never born. If your mother was never born, neither were you. How did you travel back to eliminate your grandfather initially? Scientists, philosophers, and writers have proposed various methods to circumvent this issue. Stephen Hawking introduced the chronological protection conjecture, stating backward time travel is simply impossible. The universe prevents any opportunity for temporal regression. Cause and effect remain sacrosanct and tightly policed. Igor Novikov contemplated something similar. His self-consistency principle suggests you can travel backward, but you cannot alter what already happened. If you revisit an earlier page in the block universe's book, you cannot rewrite what's written. Attempting to eliminate your younger self will fail. Perhaps the weapon malfunctions, maybe they sneeze and you miss. Try as you might, success proves impossible. But Novikov's principle doesn't work in all cases, as researchers Barak Shoshani, Jared Wogan, and Jacob Hauser demonstrated in papers published between 2020 and 2022. They showed that with certain scenarios involving objects changing properties when meeting their past selves, self-consistency fails. This peculiar paradox cannot be explained using Novikov's principle. However, according to these researchers, it can be explained using parallel time streams, the many worlds of quantum mechanics. They argue time travel to the past is only possible if you emerge in a different stream than you departed. This provides a potential solution to the grandfather paradox. If entering a separate time stream when traveling backward, you can eliminate that stream's version of your grandfather, knowing the version crucial to your logical existence remains alive in the stream you left behind. Your free will is restored, granting choice to do whatever you want. It's possible using many worlds to circumvent the Bootstrap Paradox. In our tale of the time traveler saving their teenage self, the letter's origin wasn't clear. No one seemed to write it, but perhaps we were missing characters from our story. The version of you in time stream A could write the letter, travel backward to time stream B, and give it to their younger self. That teenager then chooses physics, matures to invent the time machine, and travel backward to time stream C to give their teenage self an apparently authorless letter. So we can explain the Bootstrap Paradox away, but we need 3 versions of you existing in 3 separate time streams to accomplish this. If that seems like using a sledgehammer to crack a nut, you're not alone.
It could be a shining example of how easily humans can tie themselves into intellectual knots. The endless array of yous, each slightly different from the next, playing out every possible outcome of every possible event in constantly fracturing streams along the great river of time. And so, as we travel along our world lines at varying speeds within the great block universe around us, time travel to the future is not just possible, but has already been accomplished and is being done every day. Traveling backward remains less clear, but it seems plausible, at least on paper, with a little helping hand from the counterintuitive world of quantum mechanics. For now, we'll just have to make do with memories of yesteryear, safe in the knowledge that the past is very much still out there.